So anything that models climate, mathematically we call a global climate model, or a GCM. And they're based, they're mathematical equations, and they're based on physical laws. So so you can imagine how large the planet is, and all of these things we need to know in order to say something about climate. These models can get quite complicated, and we start off with simplified models. Now, the simplified models must be able to describe those large-scale processes that I mentioned earlier. So the basic ones would be the circulation processes. So as I said, velocity, so wind velocity, which is wind speed, and temperature and pressure, they're all very important things. So we need to know information about these things accurately in order to say something about climate. So we call these variables essential climate variables, or ECVs. There are many more. So greenhouse gases, water vapor, other things like that also are essential climate variables. And we need to be able to model these. Use our GCMs need to be able to tell us something about those essential climate variables. And the more essential climate variables we include, and the more accurate we want it to be, the more complicated it becomes. So I want to show you a picture now. So let's go to this one. So climate refers to the whole globe. So everywhere on the planet, we want to know something about climate. So we need to know something about temperature, pressure, and wind velocity everywhere on the planet. But it's impossible to do this at every single point. So what we do is we put grid cells all over the Earth. Okay, and what we say is, oh, okay, let's assign values to these variables on the cells, and that will tell us something about climate. And then we can use our models to see how these variables on the grid cells will evolve. Now, because the mathematical equations are so complicated as they are at the moment, and with current science, we can't actually solve them mathematically or analytically, we say. But we can solve them numerically. So we use approximations and ask a computer to do it for us. And now this is something that's relatively new, because computers aren't that old. If you think about it, they're only a few decades old, and even younger are the supercomputers. So this is a picture of a supercomputer. So these are the computers that can do very, very fast, lots and lots and lots of calculations. So this is the K supercomputer that's in Japan. I was in Japan in January, and I took this photo. This is not multiple computers, this is one computer. And to give you an idea of the scale, this is one floor of a building. So possibly maybe the size of 10 classrooms. So we have these supercomputers now that allow us to do very, very fast calculations, and lots of them. So what we can then do is say, okay, well, if I've got these supercomputers, I can take smaller grid cells. So I've got more information about the essential climate variables, more locations on the surface of the planet, and I've got a more accurate model. Okay, but so that's models. This is not enough, though, to tell us everything about climate, because we don't know how. So a mathematical model can tell us how it evolves, but we don't know how to initialize it, how to start it off. So satellites, so observations and data become very key in this part. So satellites, very, very helpful for looking at the surface of the planet. This is Aeolus. This is a European Space Agency satellite that is going around so orbiting the Earth at 320 kilometers high. And it's taking measurements of wind speed. Okay, so as I said earlier, very important in determining weather and climate, wind speed. There are others. So there's a constellation of 3 satellites, METOP A, METOP B, and METOP C, that are also taking measurements of wind speed, but also of some of the other variables. So this information is now coming in thick and fast with the development of satellites, helping us with our models of climate and helping us say something more about the climate and where it's going to go. So the other things that we can do with satellites are produce images. So this is an example of an image taken of the UK and various parts of Europe. There's two images there, and they're 1 month apart. And this is very helpful for monitoring climate. So modeling climate and monitoring climate are both very useful. This one here, what we're seeing on the left is green, mostly green, and changing into brown within the space of a month. So a month is quite a fast time for vegetation to be developing like this. And so we can monitor these kinds of processes and say, okay, is it climate change? What's happening here? Compare it to models. What do we put this down to?